I'm going to talk about design for longevity, and what it's all about is really when we build these kinds of systems like data warehouse and data lakes and things, it's a huge investment for the client that wants to have it. And I think we should strive to build something that will last, not just for 3 years or 5 years, but we're talking about 15 to 20 years, should have the ability to handle changes within our solution in such a way that it can still work and still deliver value for the business. So remember, when I talk about this, it's all about create an architecture from that we need to have the system to have a long life cycle. Quickly about me, I'm Patrik Lager, a senior consultant at Top of Minds, been in the area of information management for plus 20 years. I work within something called the Focal Group with the development and standardization of the Focal framework, which is part of the ensemble modeling area. I work all over the place. I work as an enterprise architect, but as well as a developer. I think it's good to get my hands dirty from time to time with the data to really understand how things are. And also I find it very interesting to work with strategies and goals and stuff within a company. I will set up a definition. This is not by Webster or anything. It's just for this presentation. I call a thing an analytical solution. It's just the ability to group these things that we talk about, data warehouse, data lake, lakehouse, cloud warehouse, and whatever we want to say. It's about a system that stores, represents, handles data for multiple analytical purposes. So yes, instead of only talking about data warehouse, because what I'm going to present is affect all of these kind of solutions. And why is that the case? Well, it's because all of these kind of solutions, these analytical solutions, they have an ingestion area where they source in data, and this comes from multiple local information areas, IT system, it's local data models, a lot of local semantics and local way of identifying things. On the other side, there is an access area where we have multiple user groups, multiple analytical and report requirements, and the need for multiple granularities of data. And between these two sort of layers within the architecture, there is a many-to-many relationship. So one user group can need multiple different systems to handle their data need, and one system can be used by many other groups of users. So we end up with an architecture that sort of have a many-to-many relationship between the sourcing of data and the usage of data. And this is a challenge from when you build something that will last for a long time. So we normally build like this. So we have certain sources, we place them into some kind of area, and then we build our solution based onto the access area. And now you can fire the poll, so to speak, in the chat, Christian, because there is a. I want to understand how many people think that this is a good way to build these kind of analytical solutions, data warehouse, data lakes, lakehouse, and so on. So it's a very easy question. Just a yes, no answer on that one. So we will come back and look at the answers at the end of the presentations. So what I'm talking about when we're trying to achieve something that has a longevity of this kind of solution is that we have an architectural layer that handles the many-to-many relationship. And the definition for this kind of layer is that data should be structurally and semantically source system agnostic. So you disconnect the direct dependency between source of data and usage of data. Also, the data should be represented in structures through a physical implementation pattern with the ability of non-destructive change. And we do not implement business rules in the physical structures. You can sort of force business rules up on the data by metadata, such as indexes and cardinality rules and stuff like that. And this is done to mitigate the possibility of cascade of change. The cascade of change is something that when something is changing, it will cascade its change throughout the whole solution. And when you come to older solutions, so to speak, some things that systems that have existed maybe for 7, 8 years, there is a lot of usage of data and there is a lot of sources of data. And you want to try to avoid this cascade of change. Because when we are building these systems, we are working in an environment, we are setting up a system that is always in flux. It will always change. Remco had a good point here 1 or 2 weeks ago on LinkedIn when he said, well, the only thing that is constant is that our data model will change. And it's the same thing about these kinds of solutions. If it's not changing, you probably do not have data in your solution or you do not have any users. So then you can discontinue the solution anyway. But if you have users and you have data, you can be assured that this will change. They will always come new requirements on new data and new ways of look at data and so on. At the same time, we want to have a fast time to market. But on the other hand, we also want to be able to maintain the solution. So these three somehow has to work together within this kind of solution. And to handle this sort of all the time change that we have in these systems, we need to be agile, right? And I'm going to talk about 2 kinds of agility. I'm going to talk about macroagility and microagility. And these two, to create a system that has a long lifespan, need to exist together. The one without the other, it doesn't really solve the issue. So you will need both macroagility and microagility, and they should work in tandem with each other. So let's start about macroagility. So what is that about? Well, of course, it's about to handle large changes. It's about IT landscape changes, like you get an influx of new sources by an acquisition of overlapping data. Maybe they buy a company to grow their customer stock, and all of a sudden you inherit a lot of systems into your IT landscape, and those has to go into your analytical solution. But it's overlapping data. It's data that's sort of you have already modeled somehow, represented it. You might need to discontinue and replace an old source, and it might be a big ERP system and sort of that is sort of intertwined with almost everything you're doing in your analytical solution. Or you will need a new different usage of data from a new analytical purpose where they need a lot of data. It's not only a sales report for John Doe down in the basement, but this is sort of a full-blown enterprise view of data they want to do something with. So they need to access a lot of sources. So you need to find a way to achieve this, to handle these kinds of situation in a smart and flexible way. So how do we achieve macroagility then? Well, we just go back to the fundamental definition of data warehouse. So it's subject-oriented, integrated, and we have time variant and non-volatile. But for the macro agility, it's mainly about the subject orientation and the integration. And now I will try to explain how I look at it. The subject-oriented for me is to represent data by core business concepts. That's our person, event, things, places, other concepts that the business talks about, the way the business describes itself. We should not store data by source system in this layer. Remember, you can have a staging layer or whatever, but in this layer, there is not by source system, and it's not either by a specific process. Even if Sean had a really good presentation yesterday about how to find out core business concepts and attributes within those, and using exactly that, using a specific business process and talking about what, when, who, those questions to find out these things. But then you sort of represents the data by the core business concepts and the relationships, not creating a model for each and every process by itself. Then they have the other part is integration. Well, for me, there is different level of integration. And the first level is about sourcing of data. We need to get our hands on the data. It could be streaming, batch, pull, push, it doesn't matter. We just need to get our hands on the data. That's the first step, which was really funny when 10 years ago or 15 years ago when the data lake came along, and they say we are so fast at integrating data, much faster than a data warehouse. Well, it was the only thing they did was sourcing. They did nothing else with the data. But we also want to sort of change the data, transform the data into a common model. When I talk about common model, I really talk about the subject orientation, about co-locate data from the source representation into this business, core business concepts and the relationships between them. The second level is that we don't want to have duplicates of instances of data. If we have a customer residing in 5 different source systems, we only want the customer to exist one time, right? So we have some kind of key integration, instance integration to remove the duplicates. The next level is about semantic integration. It's about that we have an IT landscape with sort of local languages. And if we have, let's say, a concept of a contract, and within that contract, we have something that the business talks about, it's called the maturity date. And the maturity date exists in 2 different contract systems. But in one system, it's called end date, and the other system is called M date or whatever. They need to be integrated onto the same attribute to be represented semantically as maturity date, if that is what their date means. The next step is even further down to the thing, is values. Sometimes you end up with list of values in column. Let's say we have an example that we have 2 systems that handles products. Within those systems, the business talks about product life cycles. So we have some kind of attribute in each system that represents a product life cycle. And the life cycles are represented by values. One and the values the business is talking about is that you could have a product in development, you can have a product on sale, and you can have a product that is discontinued. But one source represented is ABC, and another source represented as X, Y, Z, right? And to be able to remove the dependencies directly against the source when we access the data from this layer, we need to integrate it to some kind of other value string that we own within this solution, maybe 1, 2, 3, and then we map the values from the different sources onto these, so that independently of source, if you want to have all the products that are on sale, you can just choose where product life cycle status is the same as number 2. So you don't need to care about the source underneath. And the other thing is that we don't want 15 different formats of a date because it makes the data really hard to use. So we try to format dates into a common way of using the dates, or a timestamp or a percentage, and so on and so forth. If we do this, then we can achieve Microagility, because then we are able to create a structurally and semantically source system agnostic architectural layer that disconnected the direct dependencies between the sourcing of data and the usage of data by following the principles of subject orientation and integration. Now, this is all fine and dandy, and we might think it's very hard, but it's still this that makes the ability that you might change the source system or something will happen on the other side, that they don't affect each other. Because when they affect each other, you end up with a cascade of change. Let's say we have this ERP system, we have 200 reports, 50 ML scripts, and 4 AI solution built on data from this ERP system. And we have not removed sort of the source orientation on the data. If you shift that source, you don't only need to get the source in, you need to rebuild all the 200 reports and 50 ML scripts and 4 AIs. It's not very agile at that point. I have even been part of 3 projects when they have discontinued the data warehouse because they have done a major change in their IT landscape. And all of a sudden they have to rebuild all the usage of data. And then it just fails and they have to start from the beginning again. But we need microagility as well. And what is microagility? Well, it's, of course, to handle small changes. And what do I define as small changes? Well, it's more like business processes, that we have business process rules, or we want to add new data, maybe a new attribute, a new relationship, a new entity of data. And these things need to be handled in a way that is agile. And we're talking about here how we structurally represent the data in the architectural layer to handle change to this within this layer to be longevity. Let me take you an example of a simple business rule here. So if we have this rule that one customer can have many accounts, but an account can only belong to one customer, that's a one-to-many. In a third normal form way, you would then have the customer key reside also within the account key, account table as a foreign key. This represents by structurally show a business rule. But if this business rule changes because there is someone who comes along and has a brilliant business idea that, well, if we have one customer can have many accounts, but an account should be able to belong to many customers. All of a sudden, we can't have the customer key in the account table anymore. So we need to change the structure. We need to create an associative entity in between the customer and the account, and where we pull out the account key and the customer key and push it into the relationship. Now, this is what we often call about destructive change, because all of a sudden the structures changes because of a business rule change. In this case, it's not only that we need to sort of rebuild our ingestion form and how to get the data. The problem is that, and that this is not what many people talk about, is the cascade of change. So all the solutions that have used the account table to understand which customer that owns the account have to rebuild their solution again against this new customer account relation table that we set up. We have to migrate data, and we have to do all the regressions tests and all of those things. And all of a sudden, we aren't very agile in our solution. So we should not try to describe business process rules in the physical virtual data model, because that will give us a cascade of change issue within our architecture. So to achieve microagility, we should use an implementation pattern with an ability of non-destructive change, and we do not implement business rules as structural representation. So what kind of physical implementation patterns are we talking about? Well, I think almost everyone that I hear knows about it. We call it ensemble modeling as a modeling family, and we have 3 major ones: is data vault, is anchor, and it's focal. The interesting point about these 3 is that they are sort of classifying their data into 3 kind of data groups. There are association, that are relationships between entities, and business key, the way of identifying entities, and details, descriptive data of the entities. And we break these apart, and each of these sort of color has always its own construct in the physical layer. But if you look at a ensemble model, at this level, when you sort of zoom out and only see the colors, this could be an anchor model, this could be a focal model, and this could be a data vault model, because all three of these follow the basic rules of breaking up the data. And how does that help us then when we are doing building, when we want microagility? Well, we can incrementally grow the model with no destructive change. In this example, we have a small data model where we have a sale represented that's integrated together with customer and employee and store and sales line and product. Now the business comes along and say that we are very interesting to understand which product that sell most, who is the supplier of the product that we sell the most. So we want to apply supplier into the model. Now, so a supplier, the rule that we have today is that a supplier can have many products, but one product can only belong to one specific supplier. So from a third normal form perspective, then the supplier key would end up in the product table. But this is not how an ensemble model works. An ensemble model will always create a relationship construct, an association, the green table, to hold the relationship independently if it's one-to-one, one-to-many, or many-to-many, to achieve that a new area can be absorbed into the model without affecting anything else within the solution. Now, if you somehow want to test your solution, you can just make a mind test on your own, maybe in your home or now. You say, if a source of data is replaced, if you remove a source and replace it with a new, would you need to rewrite any of your reports, machine learning solution, and AI solution? If you do, you are missing some macroagility, and there is a danger of cascade of change in your solution. And if you add a new data areas like an entity or attributes or relationship, will you need to change any existing code or structures? Because then you have destructive change and you are missing some microagility and you are in the danger of cascade of change. Now, so the architecture for longevity, as I said, is about structurally and semantically source system agnostic, that disconnect the direct dependency between the sourcing of data and the usage of data. And we use an implementation pattern with the ability of non-destructive change, and we do not implement business rules in the physical structures. And this is done to mitigate the possibility of cascade of change, because that will break your analytical solution in the long run when one of the larger or smaller changes happens, and it cascades up to all the reports and analytical functions that you have built over the years. Now, Christian, what did we get as an answer on this? Was this a good way to build these kind of analytical solutions?
The results are in, it's 14% yes and 86% no.
Okay, so 86 doesn't like this, 14 likes it. Okay. And this is something that I was sort of thinking about yesterday through all this good presentation. It was really fun day yesterday. But there was one thing that came back to me. It was the data vault approach on this. And it's or at least from what the vendors told us. And the thing is that it's now I'm going to be I become the public enemy of data vault here, but I'll do it anyway. So the thing here is that when we do, but somehow the data vault, when we talk about it as a de facto, they talk about the first levels of integration that we need. Yeah, we need the data, and then we need to co-locate it into hubs, and then we need to remove any kind of duplicates. So we have instance integration. When it comes to semantic integration, it doesn't talk that very much on attribute level. So a lot of times, this is how it's presented, that we sort of integrate on the hub level. the key level. But we then have satellites representing sources. And as I described to you at this point, this will still have a direct dependency on source. So you will have a cascade of change in your system, even if you have done sort of the skeleton integration. But without the semantic integration, you will end up with this danger.